All right, class, this week we're going to be looking at measures of central tendency, specifically the mode, the median, and the mean. And we're going to be dealing with kind of specifically looking at like finding the centers of distributions, right? That's what central tendencies are all about. We collect all these data in a sample, and then hopefully our sample, whatever we've collected, makes a nice distribution. I have here pictured on screen on the far left, there's the normal distribution, and then you have a negative skew and a positive skew. And so with each of these three types, mode, median, and mean, where are you going to find those within these distributions? What does it mean? What is a negative skew going to do to the mode, the median, and the mean? How is it going to affect how I'm thinking about where the middle of my distribution is? And often we're interested in the middle of the distribution because typically when we take a sample, we're trying to make inferences, right? We're trying to say something about some population or some group. And for good or for ill, we typically use the average of the distribution that we're talking about to kind of categorize whatever group of individuals it is that we're discussing. And that has its own pluses and minuses, using the mean to kind of like say, okay, well, I don't want to talk about either extreme, so I'm just going to say that everybody's like the average. That has its own drawbacks in statistical research. But what we want to do is we'll look at each of these three different types. So starting with the mode, this one is kind of the least useful. You'll see it used the least in research studies. It's just the number in the distribution that occurs with the highest frequency, right? Which one of our numbers shows up the most? And I have a data table from last week looking at resting heart rates. What I've done is normally it's much easier to deal with our data if we write it out in an ordered series. So you can see I've just taken all the numbers from the table and written them out in order here. And then as I'm looking at this and wanting to, so I have a negative skew, I have a positive skew, and so where's the mode going to be? So the one nice thing about the mode is that it's the easiest to find when just looking at a distribution, right? Where's the peak? So here's the peak, here's the peak. Whatever number lines up with the peak of the distribution, that is going to be the mode, right? Because that's going to be the number that appears with, right? Because this is frequency versus, right, some other measurement. And whichever number has the highest frequency, meaning it's the peak value, that's the mode. Now, in our resting heart rate data, if you kind of look through, 73 is the only number that appears more than once. So this automatically is going to be the mode. And that's one of the weaknesses of the mode, right? 62, what if 62 had appeared twice and not 73? Well, then 62 would have been the mode, but that's nowhere near the center of this distribution. So the mode really can be kind of a tricky value to work with, which is why I think that it's often not found in very many studies. The one positive thing about the mode is that it's really the only one of these measures that we can use with categorical data. So the mode is just the thing that occurs the most within a distribution. Well, if you've got nominal or ordinal data, you can find a mode. There is going to be one of those categories that appears with the highest frequency. If you're dealing with, for example, if you think back to last week's flavors of ice cream, chocolate was the thing that appeared with the highest frequency. So that would be the mode. But I wouldn't call it a central tendency in that case because flavors of ice cream, that's nominal data. There's not an order, so there can't be a middle. And so if you don't have a middle, then we can't really talk about anything, but you could, if you were doing a study with nominal data, you could find the mode and talk about the mode, the thing that appeared with the highest frequency. But you can't find a median. You can't find a mean, right? The median and the mean are quantitative values. Now, you might be able to make an argument for using the mean with ordinal data, but because there is a natural order there, and maybe there's a middle. But the problem with ordinal data is we don't really know if the difference between each rank is equivalent, and so it's really hard to nail down the median in those types of situations. So for us, that's the mode. What is the thing that occurs with the highest frequency? The next one we want to look at is the median, and for this, it's the data point, it's the number, the value, what is in the exact center of your distribution. Often it's also called the 50th percentile, meaning that wherever the median is, half of the data points are behind it and half of the data points are in front of it, right? It's the exact middle of the distribution. And one thing to keep in mind is just because it's the number in the middle, that doesn't mean that it lines up with the bulk of the data. It doesn't have to do that. We'll look at some examples where the median is not in the middle of the bulk, right? It is the middle number, but that doesn't necessarily mean that it's exactly in the dead center of the bulk. Okay, so here's an ordered series. And so when you're finding the median, you have to write everything out in an ordered series because we need to know what the middle value is. So I have the ordered series there. You can find the median location by taking, so n represents the number of data points in your sample. In this case, for us, it's 8. So I would take 8 plus 1, which is 9, then divide that by 2. And I get 4.5, which is odd. So you might say to yourself, okay, if I'm going to count this off, right? 1, 2, 3, 4.5. Okay, so there's the median. And there's not a value there, right? It's the number in between 69 and 73. So what you have to do is you have to take those two numbers, 69 plus 73, and then divide them by 2, right? Get the average. And whatever that thing is, whatever that number is, that's going to be the median of your data set. And so the crazy thing about the median is that it's not even a value that's in, you won't find that number in our sample anywhere, but it's still the median. So that's one of the weird things about the median is that it may not even occur within the data set, which is another reason why you can't really use median in categorical data sets, right? You have to have either ratio or interval data. You have to have that quantitative data in order to really even think about or talk about the median. So that's that. That's what the median is, and that's how to find it. What number is in the dead center, is in the exact middle of your distribution. Now, so the last one of these is the mean, okay? And the mean is probably the most used of all of these things because it's just the average, right? It's the algebraic average of the data set. So you're just going to take all your numbers, right? All of your numbers, add them all up, and then divide by the total number of things in the data set. So for us, okay, so here's the equation, right? You'll see this in the textbook. This is called X bar. And it just, whenever you put a bar over a variable in math world, that just means average, right? We're looking at the average of X, which is all of the numbers in our sample. So that equals the sum. So we have the summation sign. So I'm going to take the sum of all the values in the sample, meaning I'm going to take all of these and add them all up. And for us, this adds up to 571. And then I'm going to divide it by the total number of values in the sample. And for us, that's 8. Okay, so this thing is going to be 571 divided by 8, which equals 71.375. And that's the mean. And the mean has its advantages and its weaknesses. One advantage of using the mean is that people understand what you're talking about when you say that, oh, this is the average of all of the data in the set. We take averages all the time. We understand what an average is. The mean does have some weaknesses, and we'll talk about those in just a second. But for me, it's a straightforward calculation. So, okay, if your distribution is normal, meaning that it's bell-shaped, it's symmetrical, what we can do a few things. Number one, with normal distributions, we know exactly where the mode, median, and mean are. Well, we always know where the mode is, right? It's the highest point, right? So there's the mode. And because this thing is normal, right, because it's symmetrical, that means that there's the same number of values over here as there are over here, which means, guess where the median is? Yep, it's in the exact same spot. There's the median as well. And due to the nature of normal distributions, when you sum everything up and divide by the number of things, the mean ends up being right here in the center as well. So with a normal distribution, the mean, median, and mode are all in the same place. And so that makes them really easy to talk about, really easy to find. And it's one of the reasons why normal distributions are so nice, right? All of the central tendencies are the exact same value. So we'll come back to this idea. We'll come back to this idea in a couple of weeks when we're looking at the sample distribution of means. But that's where you find them in a normal distribution. Things are a little bit different when you have skewed distributions. So here's our skewed distributions right here. Again, the easiest one to find is the mode. Okay, you just look for the peak. Oh, there's the mode. There's the mode, right? Mode. Okay, so what we need to think about and what we need to figure out is we've got all this extra data here, right? This tail, the tails, what are they doing to the median and the mean? Okay, and this is why we call them skewed distributions, is because the median and the mean are going to be pulled in the direction of the tail. And for these things, the median is not pulled as much, so maybe, I'm just guessing, maybe the median is going to be right here, so there's the median. Right, that's the number that's in the middle of the distribution, median. And then the real weakness of the mean, I'm going to do this in this color this time, is that the mean, that's not very legible. Not that my handwriting is very legible anywhere, but the mean is very influenced by outlying data, okay? These outliers, these large numbers, pull the mean away from the middle of the distribution. So that's the biggest weakness of the mean, is that if you're dealing with skewed data, the mean is not a great representation of the bulk of the population because it's pulled so far away from where that bulk is. You might be, in cases where you know the data is skewed, you might be better served by using the median in your study instead of the mean, because it's closer to that middle, to the true middle of the bulge of your data, of the bulk of your data. One of the other things that the book talks about, it talks about a trimmed mean. So to kind of get away from that weakness, is they say, okay, well, let's just cut the tail off, snip, and we're going to ignore all this data. And so the mean might have been here before, but snipping those high values off nudges the mean back closer to where the actual center is. But doing that can be really dangerous because it biases your study, right? Those people were in your sample for a reason. And if you cut them out, you're introducing some intentional bias into the study that you're doing. And you need to, if you were to write it up this way, you'd have to defend that action. You'd have to be able to say, well, I cut these folks out of the sample because, and have a really solid reason why. Otherwise, your study wouldn't be valid anymore. So that's what a trimmed mean is we're eliminating outliers to lessen the effect of the mean being drawn away from the central bulge of the distribution. So those are kind of our big topics for this week. Let me know if you have any questions, and good luck.